Now, it's always a open invitation whenever you have code that's not working to email that to me, and I'll take a look at it first part of class. Now, if it's going to take me a lengthy time, I won't. I'll look at it outside of class, but I'd rather you see my thought process in debugging. And this is true for everybody, not just the person that sent me the code. So if you have code that's not working, send it to me. Okay. See, scanner equals new or new scanner. Okay. Initialize A, B, C, and N. They're all zeros. Okay. We get next int for the A and B, and we're passing C. I think that's part of the problem there. Now that I'm looking at it, is that you don't get C and N unless you want to pass in 0 and 0 here. Okay, so on this, I'm going to input C. C is equal to n dot next int, and I want to input n. Now this is not what the problem is, but this is a problem. Okay, so now I'm successfully passing in four values. And down here, no clue what Fermat's theorem is. Okay, and I think one that would definitely work is 3 squared plus 4 squared equals 5 squared. Okay, so it's nice to have one you can test, because if I passed in 3 squared plus 4 squared, and we're wondering if that's equal to 5 squared. That's what Fermat's theorem appears to say. Well, 9 plus 16 does equal 25, so it would check. It's nice to have one that actually works so you can see if your program is working. Okay, so if n is less than 2, else. So if n is equal to 1. I can think of one where it's not less than 1. I think that if n is equal to 0, let's try to think of an example. 1 to the 0 power plus 1 to the 0 power, anything to the 0 power is 1. No, that won't. 1 plus 1 is 2. That equal to that. Now I'd probably design this differently. I would I Probably do something like if n is less than 2, then I do this code right here. Else, this would be the case where n is not less than 2. Then I have another if statement here. Now, probably doesn't like the caret. Yeah. So here we'd want to put a math.pow. Hopefully this works on integers. A to the n plus math.pow b to the n. I wonder if that's equal to math.pow c to the n. Okay, so got that in there. Now down here, I'm going to say if, so it lights up up there because I don't have the closing parentheses. If same thing. And this may not be exactly what it's looking for, so but you'll get the idea. And then that right there. So the one issue was the caret should be math.pow. And then the other issue is this exclamation here in the front. This negates the entire thing. And I'm not very good with Boolean logic, so I don't even know what the opposite of that is. If I had to guess, it's probably like n is greater than or equal to 2, or this is not equal to this, which might be appropriate. But again, I'm not very good with that negation. Unless you know it's working opposite of what you want, I usually don't put an exclamation in front of it. Okay, so this comes down here, and if n is greater than 2, then this checks it. Now, see, I think, what does Fermat's theorem say? Fermat's last theorem states that no three positive integers, a, b, and c, satisfy this equation for any integer value of n greater than 2. Greater than 2. Because if I had less than or equal to 2, let's just run that and see it. That's bizarre. Why it doesn't. I saved it last time, didn't I? There it goes. You have to save it. Yeah, I didn't notice the pattern when it happened last class, but this time I did because I saved it and it immediately appeared. I don't know why I didn't think of that last time. Okay, but if I did 3 here, 4 here, 5 here, and 2 for the power, comes up and tells us the Fermat was wrong because that's our standard 3 squared plus 4 squared equals 5 squared. That's a standard triangle in the Pythagorean theorem, and so that's working. Well, what Fermat's theorem is really checking is to see if this. He said that if it's greater than 2, that there's nothing that'll cause that to work. So if we did punch in something, then this would say, hey, oh, whoa, Fermat was wrong. There's nothing that'll give that to you. Otherwise, if Fermat's not wrong, okay, now I'm starting to understand the coding better here. This should be based upon that. And at this point, I really don't even need to do this check because if this is true, Fermat was wrong. Otherwise, then you just simply say it does not work. Okay, probably missing some curly braces or have too many or something. Let's see. No, I think that's right. Okay, so let's run that now. Now, if you put 2 in, it'll ignore you, not say anything, but that's fine. So if I tried like 3, 7, 9, they put in the 5th power. Comes up, tells us no, that doesn't work. Okay, so that's how you'd fix that particular bit of code right there. So let me go ahead and close that project. And let's continue on in the book. Now again, don't hesitate because it's a important concept people have to get done in programming. Being able to debug what's going wrong with your program. Okay, we're to chapter 7. Last part of chapter 6 was covering factorials and was a much more important topics that I could see in there. We talked a little bit about loops already. So this is talking more about them. We got the while statement. You have well, we've already had an assignment on it, somewhat. So probably not. Okay, yeah, you feel pretty good with the while already. Oh, that's interesting. So, like, what another application is running on my side? Oh, okay, okay, yeah, that's fine. Now we have our initializing. So we have a initializing a variable, and then we have our condition where we check. This will return true or false. And then we have our increment, decrement, or whatever uh, mathematical calculations being done in that variable. Here's a bit of code where I'm passing in a number. And while n is not equal to 1, it comes out here and does this. And this is checking to see if it's even or odd. This is the percent is the modulus, the remainder operator. So when it does n percent 2, that's going to do the integer division and return just the remainder. And if it's equal to 0, so like if you got 8 divided by 2 is 4 with a remainder of 0. So if it's got a remainder of 0, n is even. And you can divide by 2. And if it's n is odd, then it's got a remainder of 1. So, and it just comes down here automatically and does this. Let me think about this. Okay, they replace it for some reason with 3n plus 1. So that's what this is doing, 3n plus 1. That seems such a strange calculation when this one's just dividing by 2. Now, sometimes it's useful to generate a table. And let's look at an example of that. Let's say I want to convert from Fahrenheit to Kelvins. So public static, I'm not going to return anything, so it'll be a void. Print Fahrenheit to Kelvins table. Now, instead of hard coding it, I'm going to do a beginning parentheses. I'm going to ask for the starting number. I guess the integer is probably good as anything. So integer start, integer end. End is probably a reserved word. Ending. So I'm going to need to keep track of like an account index. So int index. And initially, my index is going to equal to my starting value. Now I'm assuming integers, so I'm going to go by ones. So while my index is less than or equal to my ending number, then I'll do this conversion. Now what I'm looking at is perhaps I might have 30. This represents degrees in Fahrenheit. And I want to convert that to kelvins. So this will be my code here. Convert to kelvins. Now I need to do something with my index. So I'm going to increase my index by 1. So you declare your index, you initialize it to a starting value, it's using your condition in some form, and then you're changing it in some form, adding, subtracting, multiplying, whatever the math calculation would be. Fahrenheit to kelvins. Three Fahrenheit to kelvins. Okay, so the formula is we take whatever degrees we have. That's this right here. So we take whatever degrees we have, we subtract 32, multiply it by 5/9 plus 273.15. That seems so weird. Okay, so I'm going to need a variable for kelvins. I'm guessing it'll need decimals. So then Kelvin is going to equal to beginning parentheses. Why is there a beginning parentheses? Well, my formula has a beginning parentheses. Then my index, which is my Fahrenheit. Better word for index might be Fahrenheit. Then you can see exactly it self-documents. Minus 32, closing parentheses, times 5, and I'm going to do a 0.0 to make sure that the integer and double division don't mess me up. Divided by 9. Plus 273.15. 273.15. Okay, so now I'm ready to print out my table. I need to print headers up here. So I'm going to say system.out.printf Fahrenheit. Then I'll do a /T for tab stop. And then kelvins /n system.out.printf. Some lines there. Some lines here. /n. Those are my headers. Headers should be above your while loop. Down here, system.out printf, and I want to have a %d. This is going to be my index. So this will be my Fahrenheit. /T, I might have to do two /Ts, but I'll come back to that. And then my Kelvin, which is a %.2f, rounded 2 decimal places, /n, and then I'll pass in index, which is my Fahrenheit, comma, and then my Kelvin. I think that's it. Let me run it and see. Did I run it? It's just going slow. Would say maybe I ran programmed an infinite loop, but I didn't. Boy, I better wake up here. It's doing exactly what I said. Nothing. Okay, so I need to declare start ending and system.out.print input starting starting temperature. Then start is equal to end dot next int system.out.print input ending temperature. Ending equals end dot next int. Now call that print Fahrenheit to Celsius table. I'm passing in my start and my ending. Again, those do not have to be named the same as your declaration down here. Can be, but don't have to be. Okay, so I'm gonna go from 3 to 20. Now 3, let's first check it for accuracy. 3 should be 257.04 around it, which it is. Okay, so that's working. Now, I mentioned I may need another tab stop. This went to this tab stop, so at least needs one more, maybe two more. We'll see. So when I'm printing it, need another /t here. Okay, 3 to 5. And that looks good. Now there's different ways you can test or you can center this. One way is to pad spaces on the front, and that's a little bit more challenging. You have to figure out what the length of your string would be if you convert it, and just start putting spaces on until it meets a certain length. But we won't worry about that for now. Now I could alter this. Maybe I want to also ask him for the increment. So I'll say system.out.print input increment. And I need to invert another variable. I'll call it increment. It's equal to n.next double. And up here, say double increment. Now what this is going to allow us to do is we can put in like a 1, 2, a 0.1, and that'll increment it by that amount. Also need to declare it here. Yeah, hide that. So then down here, where I'm increasing it by 1, I'm going to increase it by the increment. It doesn't like something there because I'm taking the index, which is an integer, and I'm adding on a double and trying to put it back into an index. Okay, so index should be a double. You can't You can't take like 3 plus 0.1 and put it back to an integer. So put 3, 5, and I'll put in 0.2. Yeah, it didn't like something there. Format conversion. So going from double, because I said index was a double, so this should be 0.0f. No, let's just say percent f. There we go. I'm surprised that didn't give me an error at run or compile time. Okay, 3, 5, 0.2. And I could have just took that decimal places, but that's okay. Now notice when I have all those zeros there, it puts it one too far out. So you can either keep all those places there or round it. Round it 2 decimal places. So do 1, 3, 0.2. And that looks better. Okay, so again, you can build tables with this. That's about math.log. The log table is not as useful as it once was. So it makes a good example of iteration. Math.log computes logs to base E. Now they use the word final here. It says the first line stores math.log base or of 2 in a final variable to avoid computing that value over and over. Last line multiplies x by 2. So that's where we're multiplying by 2. Now you might say, well, why would I do that? Well, if this was in a loop, then you don't want to keep doing the same calculation over and over. They don't show it being within a method, but it could be in a method. Now, encapsulation and generalization. It says write a few lines of code in me and another method and test them. When they're working, wrap them in a new method and test again. That's encapsulating. The idea of we put it into a new method is you can call it over and over from multiple places. You can bring it into another program, use it in there. So you're encapsulating that code into a particular segment. And third step is generalization. If it's appropriate, replace literal values with variables and parameters. Try to make it more general so you can use it for any purpose. See here, they got some code that they've written. Now, instead of the code being within the main program, they encapsulate it into its own method. So they put in a method called print row. We still got some issues though, because this is pretty hard coded. I is less than or equal to 6, and so forth. So this says you can replace the constant value 2 with a parameter in. That's where you put a variable in like that. Then it makes it more flexible. You can call it different ways, passing that in. I'm assuming they're going to replace the 6 here also. It may be the 1, because maybe you want to, instead of incremented by 1, you wanted to increment by 2 or increment by 3. Here it is. We replace the 6 with rows. So again, you're trying to develop this so it can generically be used anywhere. I would think another generalization that you'd want to do is replace this 1 with a increment, like I did. Whether they'll do that or not, I don't know. And that goes a little bit too much. Okay. You get the idea. Replace your hard coding with variables and make it more flexible. A for loop. Now we've talked about the for loop before. Here's an example for int I equals 1. Continue I as less than or equal to rows, and then increase I by 1. So it's going to loop from one to rows, increasing by 1, and then print row there. Over here, I use a while to do this, but I could use a for. Let me create a different method. Public static void print Kelvin to Fahrenheit table. We'll still need the start. We'll still need the ending. And still need the increment. Now we're going to need to calculate, what are we going to calculate? Kelvin to Fahrenheit. So we're going to calculate Fahrenheit. So declare that. I'm going to have my for loop here. And I think I can put a double here. I may be confusing this with another programming language. For double x equals start. That's my starting value. Continue while x is less than or equal to my ending value. And then x is equal to x plus increment. Kelvin to Fahrenheit. Five kelvins to Fahrenheit. There's my formula. Okay, so I need to calculate Fahrenheit. Fahrenheit is equal to my number I input which will be my X, because that's what's changing, minus 273.15, closing parentheses, times 9/5, and again, I'm going to put a 9.0, so I make sure I don't mess it up with double an integer, plus 32. I'm going to steal these lines of code here. Here's my header. Going to steal this line of code here. Okay, I need to swap these. Fahrenheit should go over here. Kelvin should go over here. Instead of index, this should be X. Although to be consistent, I could come here and I could put index instead of X. Okay, so %2, and then instead of Kelvin here, I want to say Fahrenheit. So, I just generically asked for that up above, so we do a print Kelvin to Fahrenheit table, start, ending, increment. And I'm going to comment out this. And what I put in was 5, so run this. Five to 7, 0.2. And negative 450.67, negative 450.67. Now, if you compare this, you got this bit of code right here. You compare that to the while. The while has a little bit more code. They accomplish the same thing, but you don't have to, the declaration is right within the for loop here, so you don't have to have that separate. The condition is in both of them anyway. And then the increment or decrement or whatever you're doing is the last line here. And so it doesn't have to be on a separate line. So it saves a little bit of code. Any questions on those examples? Okay. Do while loop I don't like. You can read that if you want. Break and continue. Skip those. Break breaks you out of the construct you're in. Continue breaks you out of the current iteration and then goes back to the next iteration in a while. I really consider kind of poor programming if you have to use a break and continue. I've never used that. That's it for that chapter. Here's an interesting one. how to do the square root. Takes the double, returns approximate of the square root. For example, when to find the square root of 9, we start with x naught is equal to 6, which is closer. We can repeat the procedure. Okay. I never have done this before. So this will be kind of fun. Of course, I guess it depends upon your definition of fun. Double number, let's say system.out.print input number to find the square root. Of it. And number is going to equal to n.next double. Then I'm going to call calculate square root. And I want to return a value here. So I'm going to pass in a number. And I want to return the value, so I'm going to have an answer. Just show another example of returning a value. So then down here, I'm going to have public, static, void. No, not void. I'm returning a double. Calculate square root. And then I'm passing in double number. This is actually probably would not be bad in terms of recursion. But it's so easier to think of it in this terms. We're going to need to calculate this, but we want some kind of trigger to know when we're done. So I'm going to have a Boolean that I'll declare. And I'll set it to true initially. So then I'll say while not done, I'm going to continue. Now I'm going to need a variable to calculate that. So I'll say double answer. And answer is going to equal to x naught. Okay, so x naught originally is the number I'm going to pass in. So let me create a variable called x naught. X naught is going to equal to number originally. So my formula says x naught plus a. What in the world's a? Oh, that's my number a. What's x naught then? Oh, rough guess. So my rough guess will be the number divided by 2. Then I got a, which is my number. Divided by x naught divided by 2. What am I doing? Hitting the wrong key. There. What's my insert on? There we go. Now, as I'm typing this, I'm wondering if I shouldn't have my number the same as the answer here. And then up here, I'll set the answer equal to number originally. Okay, so then this will be my number. This will calculate my new answer, which hopefully should be closer to the square root. The question is, how do I figure when I'm done? Well, I want to check this current answer against the previous answer. And if the difference is less than so much, then I can say I'm done. So I need to keep track of my previous answer. This may be tricky. What if it's always your guess? X9 is 6, which is closer. Uses X1 to calculate X2. Okay. A is always A. So that's our original number. So this should be number. This is trickier than I thought. Kind of fun. I like challenges. Okay, so then I want to check. I need to keep track of the previous number. So I got previous answer here, but I have to initialize it to something. And I think if I initialize it to number, I think I should be fine. Then I'm going to check here if answers bigger, smaller. If the absolute value of answer minus previous answer is less than 0.0001, then I'm going to call that approximation good. So I need to say not done equals false. That'll cause me to fall out of my loop. If they're not real close to each other, then I want to do another iteration. So I need to set x naught equal to my previous answer. And is there anything else we need to do? I'm probably not even close, but we'll try it. I'm going to save it so it hangs up, then I'm fine. Okay, so I got my code there. I'm not using assigned values, never used. I'm using it. Oh no, I'm not using it at all. Okay, never mind. Save it just in case. Run it. Find the square root of 2. And didn't like that at all. Uncompilable source code missing return. Oh, I didn't put a return in there. Okay, so after I'm done, I need a return answer. That's for my while. Return answer. Okay, so 2. That doesn't look good. Looks like an infinite loop to me. Okay, so let me stop that. Actually, I don't know if that actually stops it. But let's put a print in here. See if I'm going anywhere. System dot out dot print line answer. Oh, I don't say previous answer. That would be helpful. So here I say previous answer is equal to answer. Okay, so then it comes through here. It recalculates answer here. Checks those two. And then, okay, I think that might be closer. Still probably not there yet. And square root of 2 is 1.4. I'm assume. Bad habits I'd be teaching you. Equals square root of 2. 1.414214. Okay. That looks like it's working then. Now, if this throws you a little bit here, don't stress about it. I was just picking a little bit more interesting one out of the book. That's how you can program your own square root. That's probably not a bad place to hold up. So we're ready to look at arrays. And I don't want to get in the middle. I want to cover that pretty well straight through. Is there any questions on anything we've covered there? Okay. If there's any other one I could program to show you. If you want to practice with these, convert something. Google is fantastic for that. If I want to convert 7 kilograms to pounds, Tells me for the formula wise, multiply by 2.205. You got immediate check on that. So you should, going out of programming, you should feel comfortable with your basic constructs. You should be able to, if you were asked to do a for loop or while loop, you should be able to sit down there and easily program that. Doesn't mean you get it right the very first time. As you see, I have errors, but you should be able to figure out your code, figure out what you did wrong, and that's why I like bringing up people's code during class. It's not to call attention to them or anything, because we all make mistakes on that, but it's so you can see what are the thought process in figuring out your problem. Let's see if I remember debugging in NetBeans. Maybe I can show that to you. I don't remember if I need to attach debugger or not. We'll see. It's not a virus. Allow it. Okay, so put a 2 here. And which one step into? This one. Okay. Yeah, I know how to do it then. Let me show you what I did. So I got over here in line number, like on line 33, I click that. By clicking it, it puts a little red square there. This is a breakpoint. And you can put breakpoints at different places, so you're not limited to just one or two. Breakpoints are when you run your code, it's going to break out so you can examine the value of your variables at that point. Now, if you come up here and you do a debug project, this first one. This seemed a little bit confusing at first because there was nothing here. But if you click the output tab here, then this is where you put in your value and press enter. So if your code is just giving you the wrong answer and you don't understand why, this is how you debug it. Now you see this has turned this green because this is the current line we're sitting on. If I put my mouse over answer, you see it says answer is equal to 2.0. It has not done this line yet. If I put my mouse over the X naught, it says 1.0. Number says 2, and then 1 there. Now, over here in the variables tab, you see it's got the values of the variables here. Now this, go away box. This line right here has a bunch of different icons. Specifically, the one with like a code window there with a down arrow, that's a step into, where you can press F7 over and over. This will go line by line through this. So if I step into, it'll come down to here. And now if I put my mouse over answer, you see answer says it's now 1.5, which you can also see down here. It says answer is 1.5. X naught is still 1.0. You see that value down here. Now, if you keep doing F7 to go line by line, step into it, then it'll go and bring up this printstream.java. You probably don't want to go through that. So since I already have this breakpoint set, if I do this, this one right here, continue, it'll go to the next breakpoint. So it'll skip over that all that code in printstream.java and come down to the line I want. Now you can freely click these to take them off while you're doing it. Okay, so I'm sitting right here now. Let's see what my answer is. The answer is 1.5. Previous answer is 2. So if I step into, it does that line of code, and it comes down to here. So I know where it's actually running. Do that line of code, and again, you can see your values change down here. Then my previous answer changes to 1.5. And I'm up here at the while, looping through. Oops. Okay. Continue. So I click the continue there. I don't want to go through all that print stream code. So now to stop the debugging, there's this little red square here, finish debugger session. Like that. Is there any questions on how to use that debugger? And oftentimes I have a clear all breakpoints, but I'm not seeing that. So I guess this one you have to click these, take out the breakpoint, if you want to get rid of those. I'm sure there's some way to clear it all. What you're going to find is any development package you're using, IDE, if you have a debugger, oh, that makes your life so much easier. Not everybody can just look at code like me, and I can't do it all the time. I just been lucking out sometimes in class. But not everybody can look at the code and immediately see where the logic issues are. The errors are pretty easy. You got red squigglies under them. It kind of gives you an idea of what you're doing wrong. But where it just doesn't work, gives you the wrong answer. That's more challenging. And sometimes when I don't see it, I have to go into debug mode again. Some of you in some other classes, you've seen me go into it fairly often. So I'll draw a blank. It's like, why isn't this working? It should be working. Worked perfectly in my head, but it's not working perfectly now. But anyway, that's the debugger, and again, I encourage you to play with that. See how it works. Once you get more comfortable with that, you're going to find that an invaluable tool. And we'll stop there. So go ahead and